Hello again. I just wanted to share this. I found it kind of interesting yesterday evening. I found my USB AX logic analyzer, and I was, I'm still working in Circus serial programmer RCSP, and I wanted to check that logic analyzer on my SPI line. Here is the ISP that I'm working on right now. I called it the console, ICSP console. This is the circuit. Uh, Here's the logic analyzer pod. I got on eBay for really cheap a few years ago. And this board is like we can assume is any board that you need to program. Right now it has a flashing program on there. Well, to get into it, because it's rather complicated, I wrote a program to interface it in C, and here it is. It says, if you can read as A, B, C, D, E, and F, the different functions for the ICSP programmer, like A is to erase the flash, B something, C, read the ID. And what I'm working on now is read the ID. But briefly, I just want to kind of show the use of the logic analyzer at this moment. I have set it to I have set it to well, let's set it here. Let's set it to do 230 million samples and at 12 million samples per second. And let's say I wanted to trigger on the clock. I found the clock when it goes low to high when it starts, that it gives me the best result. So let's run it and then hit an A here, which would cause this to erase if I can do it all with one hand. I'm gonna tell it to acquire. Then I'm gonna come down here, hit an A, which should come out a question mark. Oh shoot, I'm running out. Okay, now it's erasing it. It's still getting the data. We might be able to send another one. Send another erase. So it'll blank it out because the reset line grabs it. And we're still triggering. So I wanted to send a seat too late. Gone. So as you see, this is working, and erase the flash, and we're no longer linking. But the interesting thing is that now we can see the waveform. Let's see what it captured. That's the data, the SPI data that it captured, right? So now let's see what that data was. So we mark it here, and then we mark it at the end here. I'm sorry, I can't do 4 things at once, but we mark it. We put these markers here. Excuse me, and we're gonna tell it to read the data. So now we come over here to SPI code and give that a click. See what comes out. Okay, it says there AC 53011 AC 8212. Excuse me again. That's what it read. That is the SPI data. That is the SPI data that is sent. Okay? So you saw that there. This is the waveform it captured that got sent from this thing here, from that program there, to the ICSP programmer, to the circuit board, and that's the code is set. Okay, now this is what I want to show you. This is the program I wrote. The function I called erase it, and look here. What do you see there? AC 530011, right? The program enable, then the erase is AC 821213. So we're missing a 13. We're missing a 13 because we haven't gone, we're right on the edge of this. So if I move it out there and tell it to decode again, there's the 13. At the end there, right there, 13. So it's that the entire erase it function, the program enabled, and the erased codes, AC82 1213. And we were happily able to capture it on the logic analyzer. So that's pretty incredible. I've had this for a long time. I just kind of bumped into it yesterday, but it makes it a lot more interesting to experiment with. Let's see if we send the other one. The one I'm working on now is the read ID bytes, and I'm having a very interesting time. I can't figure out how to get the Intel hex file bytes into my program, because if you don't know, Intel hex, every line has is the code for, you know, memory location, addresses the thing is going to go to, checksum byte, data, everything. So I'm just kind of doing the things I can now, like, you know, the erase the flash, the read the flash, the read ID bytes and things, and saving the programming, the flash for last as I work on. I only do this like for amusement on weekends, and namely Sunday for a few hours. So, well, it might get, well, if it gets too long, you can click out, but let's see if we can read that other byte. So it's the read ID bytes. So but at the same time, get this to acquire again. So I'm going to hit that, and now I'm going to hit C. This thing should blink out. It blinked out. This is not really programmed, so I mean, it's not really programmed for anything. And we'll hit the A again to catch it later. And let's hit it again just in case. Oops, sorry. So let's see what we have here. See, this pattern is different now. This pattern is different. So let's see what kind of data we have here. We'll put it. Oh, and these are the SPI, mostly MISO clock and reset there. So we'll put it at the beginning of the clock. Well, since it's out there, we can put it here. Let's see what it says. And this one, I guess we'll leave it. We can leave it out here. We'll probably get some AC50. Okay, there we go. So for read ID byte, the function read ID byte, we have send enable signal AC 530011, and the erase, I mean the read byte is 2800. So what, I'm sorry, what do we have here? Where's the SPI decoder? We have AC 530011, the enable, and then 2800. So it's in that one. I'm gonna start closing this because the video is almost over. But you can also, like, I think there it is. You can capture it down the line. Here's another instance of when I repress the buttons. I pressed the buttons a couple of times. So I got that on eBay pretty cheap, but I think like I honestly I paid like $50 and they're like $400. And it has a bunch. Let me see. There's another one. I like the oscilloscope. Let me see if I can find it here at the end of this video here. They mixed signal oscilloscope. Excuse me. I'm gonna close this one. Maybe it won't start. This one tended to take a long time yesterday to load. In the meantime, this is the program you were seeing. There's, the erase flash, read ID, bias program flash. This one is pretty simple. And then this one has three. This one has three, has the good SPI file. I have all my functions here for my ICSP. I have the main program, which is I'm working on right now. I'm trying to get it to send data from here that it reads from there and send it out to my PC. And the COM port things are a bit tricky. To have it print out nice and everything. So let's see the scope. Let's see the scope. The neat thing about it is like 5 volts. We can set it at 5 volts. And the frequency, you can give it some frequency. Let's see if it's running. I don't even know if I'm connected to it. We'll know in a minute. See triggering data. It turns on triggers, and you control the triggers by them little squares, like positive going, negative going. It should be on the clock of the processor. I don't know if it's making contact on that pin or not. Still storing data. There we go. So that is reading the clock. The processor clock, and it's kind of choppy because of the samples. Let's get it, let it acquire less, and run it again. It seems to have gotten stuck. There we go. So instead of 200 some million, we got 173 million at 12 million cycles per second. For some reason, 16 million cycles per second gives me less resolution than 12 million cycles per second. But let's see what it says. Once it stops storing down, there we go. So I have a much better pulse on the scope, and you just connect them little clippers, and you got other clippers here and everything like that. So I think it's pretty neat for the $50 I paid. It's called UsBee AX. Actually, it's a suite. It's a UsBee AX, and I got it on eBay. I think maybe you still can get it from China really cheap, and it gets like, oh, I'm sorry, I pressed something else. All programs. These are all the things they can do, like frequency data logger, frequency counter, frequency generator, digital signal generator, digital voltmeter, I2C controller, AX logic analyzer, mixed signal oscilloscope pulse counter, AX pulse modulation controller, AX remote controller. This is the scope. It took it a bit too long. Let's see what the scope this one's saying. This is just the scope without the mixed signal logic analyzer. Oh, I didn't want to make the video too long, but this is the last part. I'm gonna sit down and hack at this intercommunication between my board and the other. So there it is. And I haven't calibrated it either. I have, you have to calibrate it for voltage and what have you. And then you can move all these cursors and things and get precise measurements and everything else. Well, in an effort to keep the video short, everyone watching this, enjoy a beautiful day. Over and out. Bye.